And potential energy diagrams number 3. Once again, potential energy, reaction coordinate. You start at one level, you finish at another level, up and back down. We had that level, we had that level, and the top of the hill, that level. A catalyst is something that changes the reaction mechanism, the pathway in between reactants and products. And it changes it in such a way as to make the hill lower. A catalyst creates a new pathway in between reactants and products that lowers activation energy. My activation energy forward used to be that much. My activation energy reverse used to be that much. Instead of going from reactants to products directly, I introduced a catalyst to the system. I changed the way I get from reactants to products. I only need to get up this high on the hill now. My activation energy now, forward, is only this big. My activation energy reverse is only this big. It lowered both of the activation energies. As a matter of fact, it lowered them by the same amount. It makes things go faster. So what is a catalyst? Well, it's not a reactant or product. It is something that's added to the system that lowers activation energy. Both of them, forward and reverse. So it speeds up the rate of reaction. Hi, Tungsten. Want to say hello? Tungsten wants to say hello. Come here. Come on. Say hi. Okay. Back to work. Let's talk about the reaction mechanism. If I take a simple reaction, let's make some water. 2 hydrogens plus 1 oxygen would give you 2 waters. That's an exothermic process. If I use a particle diagram and say that's what a molecule of H2 looks like. That's what a molecule of O2 looks like. Okay, so water looks like a Mickey Mouse. Alright, so in my reaction I need 2 H2s and an O2, and I'm going to form 2 waters. That's a summary. How does it get from being this into that? You can propose a mechanism. You can't see this, but you can propose a mechanism. So maybe my first step is to break apart a hydrogen. And my second step, I'm going to break apart the other hydrogen. My third step, I'm going to break apart the oxygen. My fourth step, I'm going to take one of my oxygens and combine it with my hydrogen. My fifth step, I'm going to take the other oxygen, combine that with the other hydrogen. My sixth step, take one of those OH groups, combine the other hydrogen, make my first water. And my seventh step, take my final OH group, combine it with the remaining hydrogen, and make my other water. Maybe that's what happens. Maybe that's the order of steps. Maybe it's not. Whichever step is the slowest step, they call that the rate determining step. If you've ever been in line, you can relate to the rate determining step. The person in front of you that's taking the most time. Nobody behind them is going anywhere until they're done. So the slowest step is called the step. Is rate determining. Determining, ing. I'm off the paper here, but not that big a deal. So a catalyst somehow changes a mechanism. It creates a different series of steps. It creates a new pathway. A different series of steps to get you between reactants and products. That requires less activation energy. Here's a simple analogy. Here's the high school, Amherst Central High School. Here's the middle school. Here's Berryman Drive. Here's Washington. And here's Westmoreland. Now, here's Main Street. If I want to get from the high school and I want to get to the middle school, I suppose I could walk out the front U, go to Main Street, come on down to Berryman, come on down Berryman to Westmoreland, come down Westmoreland to Washington, and take Washington over to the middle school. What is that, Kings Highway there? I don't know. That's a potential series of steps. I suppose I could have come from the high school out to Main Street, over to Washington, to Westmoreland, to Berryman, over to middle school, to Kings. Could have done it that way. What's a catalyst? A catalyst is something that says, you know what, I'm going to make this a lot easier. I need you to go to the front U, hop into your own very personal helicopter, and I'm going to fly you over there directly and set you down right in front of the middle school. Sound like a plan to you? A catalyst is something that's going to make your pathway in between reactants and products a lot easier. It's going to lower your activation energy. I wish I had my own personal catalyst. My own personal helicopter would be pretty cool. Oh, didn't that developer Mark Croce have his own personal helicopter? Yeah, he did. That didn't work out so well for him. So maybe I'll rethink that. All right. Worksheet 2. That's homework. They're going to talk to you about, I'm going to cover the answers for a second. They're going to talk to you about potential energy diagrams. In number 4, when they say which one is activation energy, they're talking about the forward reaction. Worksheet 2 is your homework. Talk to you later.